For most of human history, the top of the world did not need a standing army to defend it. It was guarded by something far more effective than walls, radar, or weapons. It was guarded by geometry and cold. The Arctic Ocean was not viewed by military strategists as a body of water to be crossed, but as a physical barrier that marked the end of the known world. It was a place where logistics failed, where navigation became theoretical, and where the machinery of war froze into silence. In the first half of the 20th century, the great powers of the globe looked at the map and saw the polar ice cap as a permanent, immovable shield. To the Soviet Union, the ice was a roof that protected their northern flank from invasion. To the United States and Canada, it was a frozen desert that separated the continents more effectively than any ocean. There were no patrol routes through the pack ice. There were no supply lines. The Arctic existed beyond the reach of human conflict because it existed beyond the reach of human survival. This belief in the sanctity of the Arctic was not born of naivety. It was born of a hard, pragmatic understanding of the limits of naval architecture. For generations of sailors, the white void at the top of the map was a place you did not go because if you went there, you did not come back. It was a geography that exercised a veto over the ambitions of admirals and kings. To understand why this barrier was considered absolute, one must first strip away the mythology of the submarine. In popular culture, the submarine is depicted as a monster of the deep, an omnipotent hunter that roams the abyss with impunity. We imagine them as creatures of the underwater world, divorced from the surface. But this is an illusion. For the first 50 years of its existence, the submarine was not a true submersible. It was a surface ship that had the temporary mechanical ability to sink. It was a steel cylinder designed around one overriding assumption, that it would eventually rise again. Every system on board a traditional submarine exists to serve this return to the light. The ballast tanks are designed to be blown dry with compressed air. The diving planes are shaped to plane the hull upward. The propulsion systems, whether diesel or electric, are engineered to push the vessel back to the atmosphere where the crew can breathe, where the radios can transmit, and where the batteries can recharge. For a submariner, the surface equals life. It is the only place where repairs can be made. It is the only place where a fire can be vented. It is the only place where a rescue ship can reach a stricken crew. There is an unwritten law that governs the profession, a rule drilled into every cadet who ever stepped onto a wet deck. If you cannot surface, you are already dead. The Arctic ice cap breaks this law. It places a solid, impenetrable lid over the ocean. It turns the submarine from a vessel of war into a prisoner of physics. If a submarine dives beneath the ice, it voluntarily severs its connection to the world of the living. It enters a hydraulic system where there is no up, only down. If a fire breaks out under the ice, there is no way to clear the smoke. If a pipe bursts and the pressure hull begins to flood, there is no way to blow the tanks and cork to the surface. If the reactor scrams or the engines fail, the submarine does not drift to safety. It drifts upward until it hits the ice, pinning the crew against a ceiling of frozen water that is harder than concrete. For decades, this reality made the Arctic a no-go zone. Naval commanders looked at the ice and saw a coffin lid. They understood that to take a ship under the pack was to accept a level of risk that was statistically indistinguishable from suicide. However, the ice itself is not merely a flat sheet of frozen water. If it were, perhaps the risk would be manageable. But the Arctic ice pack is a chaotic, violent landscape that is constantly in motion. It is driven by wind, currents, and the rotation of the Earth. The massive flows, some of them miles wide, grind against each other with the force of tectonic plates. When these flows collide, they buckle. They form pressure ridges that rise high into the air, jagged walls of ice that can block the horizon. But these visible ridges are only the tip of the structure. Just as an iceberg hides its mass, a pressure ridge hides its danger deep underwater. Beneath the surface, the collision of the ice creates ice keels. These are inverted mountains, jagged spurs of ice that plunge downward into the black water. An ice keel can extend 50 feet, 100 feet, or even 200 feet below the surface. They hang there like stalactites in a cave, waiting for a vessel to pass beneath them. Navigating under the ceiling is not like sailing on an open sea. It is like flying an airplane through a canyon in the dark, where the roof of the canyon varies wildly in height and the pilot has no map. A submarine commander moving at 20 knots might think he has plenty of water above his sail, only to find that the ceiling has suddenly dropped by 80 feet. A collision with an ice keel is catastrophic. The sail of a submarine houses the periscopes, the radar masts, and the radio antennas. It is the eyes and ears of the ship. If a submarine strikes an ice keel, the sail will be sheared off or crushed. The hull could be ruptured. The vessel would be blinded, deafened, and possibly flooded, tumbling into the abyss with no hope of recovery. This physical reality created a global consensus that held firm through 2 world wars. The Germans, the British, the Americans, and the Soviets all operated submarines, but they all respected the line where the water turned to ice. They might skirt the edge of the pack, hunting for convoys or hiding from destroyers, but they did not go deep. They treated the Arctic Ocean as a wall. Strategic planning reflected this avoidance. During the Second World War, the convoys to Murmansk fought their battles in the freezing spray of the Barents Sea, but they did not venture into the high north. The Arctic was a flank that did not need to be turned because it could not be turned. As the Cold War began to freeze relations between East and West, this geography provided a strange sense of comfort. The Soviet Union knew that its northern border was the longest and most difficult to defend in the world. It stretched for thousands of miles across Siberia, but the ocean protected it. The Northern Fleet could base its ships in the fjords of the Kola Peninsula, knowing that any American naval force would have to approach from the Atlantic. Any American submarine attempting to attack the Soviet Union would have to cross the Guyuk Gap, the choke points between Greenland, Iceland, and the United Kingdom. This funneled the conflict into predictable lanes. The Soviets could concentrate their defenses, they could build sonar nets and minefields, they could predict the vector of the attack because the geography dictated the path. This assumption that the enemy must come from the south became the cornerstone of Soviet naval doctrine. It allowed them to treat the Arctic Ocean as a rear area, a safe harbor where they could test their weapons and train their crews without fear of American intrusion. It was a white void on their operational maps, a place where they were safe. But assumptions in warfare are often just failures of imagination waiting to be exposed. The belief that the Arctic was impenetrable was based on the technology of the past. It was based on diesel engines that needed air and batteries that needed charging. It was based on hulls that were designed to fight on the surface. The strategists had not accounted for the moment when technology would remove geography's veto. They had not considered what would happen if a ship was built that did not need the surface. In the mid-1950s, a quiet revolution was taking place in the shipyards of the United States. It was a revolution driven not by the need to explore, but by the need to dominate. Engineers were working on a power source that would sever the tether between the submarine and the atmosphere. They were splitting the atom to boil water. Nuclear propulsion changed the fundamental nature of the submarine. A nuclear reactor does not breathe, it does not consume oxygen, it does not produce exhaust that must be vented. A nuclear submarine is a closed system, a habitat that can remain underwater for months at a time, limited only by the amount of food in the freezer and the mental endurance of the crew. This technological leap created a dangerous new question. If a submarine does not need to surface for air, and if it does not need to surface for fuel, why can it not go under the ice? The question lingered in the classified briefing rooms of the Pentagon. It was a theoretical possibility that carried terrifying implications. If a submarine could travel under the ice, the Arctic Ocean would cease to be a wall. It would become a highway. It would become the shortest route between the missile silos of the Soviet Union and the cities of North America. But theory is not practice. To turn the Arctic into a battle space, someone had to actually go there. Someone had to take a ship into the white void and prove that the ice keels could be dodged and the pressure ridges could be survived. It would require a commander who was willing to bet the lives of his crew on the readings of a sonar screen. It would require a ship that was built to tighter tolerances than any vessel in history. And it would require a rejection of 50 years of naval wisdom. The illusion of safety was strong, the ice looked permanent, the silence of the pole seemed eternal. But the USS Nautilus was being welded together in Connecticut, and the men who would sail her were already studying the charts of the frozen north. The unwritten law of submarines stated that you must always be able to reach the sky. But a new law was being written in the laboratories of the Atomic Energy Commission. This law stated, that if you have enough power, you can ignore the sky. You can create your own world deep in the dark, and you can take it anywhere you want, even to the one place where no one expects you to be. The Arctic was waiting. The fortress was secure, but the gate was about to be crashed. The history of exploration is often written by reckless men, adventurers who rely on charisma and luck to survive the unknown. But the conquest of the Arctic Ocean would not be led by a thrill seeker. It would be led by a man who viewed adrenaline as a failure of planning. Commander William Robert Anderson was the antithesis of the Hollywood war hero. Born in the quiet, rolling hills of Tennessee, he was a man of soft speech and rigid discipline, an officer who treated the command of a submarine not as a romantic crusade, but as a complex mathematical equation that had to be balanced every second of the day. Anderson's path to the bridge of the world's first nuclear submarine was paved with the hard lessons of the diesel era. He had served in the Pacific during World War II, fighting in the cramped, sweating hulls of boats like the USS Tarpon and the USS Narwhal. In those days, submarine warfare was a visceral, terrifyingly intimate experience. You engaged the enemy on the surface at night, watching the tracers fly over your head. You listened to the screws of Japanese destroyers churning the water directly above you while the air in the boat grew foul and the batteries died. From these experiences, Anderson distilled a philosophy that would define his career: panic kills, but preparation saves. He understood that the ocean was an unforgiving environment that magnified small mistakes into catastrophes. He was drawn to the submarine service precisely because it stripped away the noise of military politics. At 400 feet down, rank and influence meant nothing. The ocean did not care who your father was. It only cared if you had closed the valves correctly. But Anderson was only half of the equation. He was the operator, the man who would steer the ship. But the ship itself and the revolutionary power source inside it was the child of a man who was widely regarded as the most difficult, abrasive, and brilliant officer in the history of the United States Navy. Admiral Hyman G. Rickover did not fit in. In a Navy defined by tradition, social grace, and chain of command, Rickover was a wrecking ball. He was small, frail-looking, and possessed of a temper that could strip the paint off a bulkhead. He cared nothing for uniforms or protocol. He cared only for excellence. Rickover is remembered today as the father of the nuclear navy, but that title softens the reality of his crusade. In the late 1940s, the idea of putting a nuclear reactor inside a submarine was considered by many admirals to be a dangerous fantasy. A reactor was a massive, heavy, radiation-spewing machine that belonged in a concrete building on land, not inside a steel tube fighting a war. They argued it would be too heavy, too complex, and too fragile. Rickover declared war on the word impossible. He built a fiefdom within the Navy, bypassing admirals and going straight to Congress for funding. He drove his engineers to the point of exhaustion. He demanded standards of quality control that American industry had never seen before. He knew that in a nuclear system, a single bad weld or a single impure alloy could lead to a meltdown. He was a tyrant, but he was a tyrant who was right. His vision was simple but transformative. For 50 years, submarines had been diving ships. They were surface vessels that could dip underwater for a few hours to hide or attack. They were tethered to the atmosphere by their diesel engines. They needed air to burn fuel. This meant they were slow underwater, and they always had to come back up. Rickover envisioned a true submersible. A nuclear reactor does not burn anything. It generates heat through fission. It boils water to make steam, and that steam drives the turbines. It requires no oxygen. It produces no exhaust. A nuclear submarine could theoretically seal its hatches in Groton, Connecticut, and not open them again until it reached London or Tokyo or the North Pole. The result of Rickover's obsession was the USS Nautilus, SSN 571. When the Nautilus slid into the Thames River in 1954, she looked like a submarine, but she behaved like a spaceship. She shattered every record in the book. In her initial sea trials, she didn't just break the underwater speed record, she maintained it for days. She could outrun a destroyer while submerged. She could cross the Atlantic without snorkeling. She was a new species of weapon, but Rickover knew that the machine was only as good as the men who ran it. He personally interviewed every officer who applied for the nuclear program. These interviews were legendary ordeals. Rickover would bring a young officer into a bare room, sit him in a chair with shorter front legs so he would constantly slide forward, and then berate him for hours. He asked impossible questions. He insulted their intelligence. He tried to make them angry or make them cry. He wasn't being cruel for sport. He was stress testing their character. He needed men who could face a crisis, a reactor scram, a fire, a radiation leak, and remain icy calm. He needed men who would follow the procedure even if the ship was sinking. William Anderson survived the interview. He proved he had the mind of an engineer and the nerves of a gambler. Rickover gave him the Nautilus. As Anderson took command, the strategic potential of the ship began to merge with the geography of the Cold War. The United States was locked in a standoff with the Soviet Union. The Soviets had built a formidable submarine fleet and were fortifying their northern coast. The Arctic was their backyard. Anderson looked at the globe. He saw what the early explorers had seen. The shortest route between the superpowers was not across the Atlantic, but over the top of the world. A missile fired from the Arctic could reach Moscow in minutes. A submarine moving under the ice could move from the Pacific to the Atlantic in secret, bypassing the radar nets and the choke points. But the ice was the problem. The ceiling of the Arctic Ocean had kept surface ships out for centuries. Diesel submarines had skirted the edges, diving under the floes for a few miles, but they always had to turn back. They couldn't breathe under the ice. The Nautilus didn't need to breathe. The idea began to take shape in Anderson's mind and in the strategic planning cells of the Pentagon. If the Nautilus could traverse the Arctic Ocean, crossing from the Pacific to the Atlantic via the North Pole, it would demonstrate a capability that would terrify the Kremlin. It would prove that the Soviet fortress had a back door and that the door was wide open. It was a mission that combined the romance of 19th century exploration with the hard science of the atomic age. It was Amundsen and Shackleton, but with a nuclear reactor. However, the leap from theory to reality was treacherous. The Nautilus was a prototype. She was the first of her kind. Her navigation systems were designed for the open ocean, where you could raise a sextant to the stars. Under the ice, there are no stars. Magnetic compasses spin uselessly near the magnetic pole. Gyroscopes drift. And then there was the hull. The Nautilus was built of high-yield steel, tough enough to withstand depth charges, but was it tough enough to hit an ice keel at 20 knots? The charts of the Arctic were blank. Anderson would be flying blind into a tunnel where the ceiling was made of jagged, inverted mountains. Anderson approached the mission with his characteristic methodical caution. He didn't want to be a hero. He wanted to be successful. He began to study the ice. He looked at the sonar data. He worked with the engineers to install upward-looking sonar, electronic eyes that could map the ceiling just as standard sonar mapped the bottom. In Washington, the political pressure was mounting. The Soviet Union had just launched Sputnik, the first artificial satellite. The blinking light in the night sky was a humiliation for the United States. It suggested that Soviet technology had surpassed American ingenuity. President Eisenhower needed a win. He needed a demonstration of American technological supremacy that would capture the world's imagination. The Nautilus was the answer. Operation Sunshine was born. It was a top-secret directive approved by the White House to send the Nautilus across the top of the world. As Anderson prepared his ship and his crew, he knew he was walking a fine line between bravery and foolhardiness. He was taking 98 men into a hostile environment that had killed hundreds of explorers before him. If the Nautilus suffered a reactor failure under the ice, they would not just die, they would disappear. There would be no rescue. They would be entombed in the ice, drifting in a steel coffin for centuries. But Anderson trusted the machine. He trusted Rickover's obsessive quality control. He knew that the reactor would run. He knew the hull would hold. The only variable he couldn't control was the ice itself. The architect had built the perfect vessel. The captain had prepared the perfect crew. Now they had to face the one enemy that couldn't be fought with torpedoes or diplomacy. They had to face the geography of the pole. The Nautilus slipped out of Seattle in the summer of 1958, heading north. To the casual observer, she looked like any other submarine leaving for patrol. But inside, the mood was different. They were not hunting ships, they were hunting a passage. They were carrying the pride of a nation into the white void. The relationship between Anderson and the Nautilus was symbiotic. He was the brain, she was the body. As they approached the Bering Strait, the gateway to the Arctic, Anderson felt the weight of history. He was about to attempt something that had been deemed impossible for 50 years. But Hyman Rickover had taught him that impossible was just an engineering problem waiting for a solution. And William Anderson was ready to solve it. The silent revolution of nuclear power was about to meet the frozen silence of the pole. The architect and the captain were ready to open the door. In October 1957, the geopolitical sky fell. The Soviet Union launched Sputnik 1, a polished aluminum sphere the size of a beach ball that circled the Earth every 96 minutes. It transmitted a simple, rhythmic electronic beep that could be heard by amateur radio operators across the American Midwest. To the public, it was a terrifying signal that the enemy was overhead, looking down. To the White House and the Pentagon, it was a catastrophic failure of technological deterrence. The United States prided itself on being the vanguard of the future. It was the nation of the assembly line, the atomic bomb, and the transistor. But suddenly, the Soviets appeared to have seized the high ground of science. If a Soviet rocket could put a satellite in orbit, it could drop a thermonuclear warhead on Washington, D.C. The missile gap dominated the headlines. America looked vulnerable, slow, and second-rate. President Dwight D. Eisenhower, a former Supreme Allied commander who understood the psychology of war better than anyone, knew he needed a counterstrike. He didn't just need a weapon, he needed a symbol. He needed a demonstration of American audacity that would capture the imagination of the world and prove that the United States still owned the technological frontier. He couldn't beat the Soviets into space immediately. The American rocket program was struggling with exploding launch vehicles on the pads at Cape Canaveral. But he could beat them somewhere else. He could beat them in the one environment that the Soviets considered their own backyard, the Arctic Ocean. The idea that formed in the strategic planning cells of the Navy was codenamed Operation Sunshine. The name was a deliberate irony. The mission would take place in a world of absolute darkness, beneath millions of tons of ice. The objective was simple. The USS Nautilus would travel from the Pacific Ocean to the Atlantic Ocean via the North Pole. This was not just an exploration stunt. It was a strategic dagger. If the Nautilus could cross the pole, it would prove that the Arctic was not a wall, but a highway. It would demonstrate that the distance between the superpowers had just shrunk from 10,000 nautical miles to fewer than 2,000. It meant that in the near future, American ballistic missile submarines, the successors to the Nautilus, could hide under the ice cap, immune to detection, and launch missiles that would reach Moscow in minutes. It was the most dangerous idea of the early Cold War, because it threatened to fundamentally destabilize the Soviet sense of security. It turned their fortress into a vulnerability. It suggested that the Atlantic and Pacific Oceans were not separate theaters of war, but connected flanks of a single battle space. But having an idea and executing it are two different things. Commander William Anderson received his orders directly from the highest levels of government. The secrecy was absolute. The crew was told they were heading to the Pacific for routine operations. To maintain the ruse, the Nautilus even made port calls in California, acting like a standard fleet unit. However, behind the scenes, Anderson was preparing for a voyage into the unknown. He faced a terrifying lack of data. There were no detailed charts of the Arctic floor. The only depth soundings available had been taken by explorers drilling holes through the ice decades earlier or from low-flying aircraft using primitive radar. Anderson was being asked to fly a plane through a canyon at night without a map. The first attempt began in June 1958. The Nautilus headed north from Seattle, passing through the Aleutian Islands and entering the Bering Sea. The mood on board was tense but confident. The reactor was performing perfectly. The specialized gyroscopes were holding their alignment. But as they approached the Bering Strait, the narrow, shallow choke point between Alaska and Siberia, the reality of the Arctic began to close in. The Bering Strait is not a deep ocean channel. It is a submerged land bridge, a continental shelf that is barely covered by water. In some places, the depth is less than 150 feet. This is shallow water for any submarine, but for a submarine trying to go under ice, it is a death trap. On the surface, the ice pack was drifting south, driven by the summer winds. It wasn't a solid sheet, it was a chaotic jumble of flows. Anderson ordered the Nautilus deep, or at least as deep as he could go. The sonar painted a horrifying picture. The bottom of the ocean was rising up to meet them. The ceiling of ice was pressing down. The Nautilus was entering a funnel. The clearance between the keel and the seabed was measured in feet. The clearance between the sail and the ice was measured in feet. The submarine was being squeezed into a sandwich of ice and mud. Then the sonar detected the inverted mountains. The ice of the Chukchi Sea was not flat. Massive pressure ridges, places where ice floes had crashed together and been forced downward, hung like daggers from the surface. Some of these ice keels extended 60 feet down. Anderson watched the traces on the upward-looking sonar. He saw a massive block of ice directly ahead. It was deep. Too deep. He ordered the ship down. Flood negative, down angle. The Nautilus dropped, but the bottom was right there. They were skimming the silt. The distance between the top of the sail and the bottom of the ice was less than 20 feet. If they hit the ice at speed, the collision would shear off the periscopes, the radar masts, and the radio antennas. It would leave the submarine deaf and blind. Worse, it could rupture the sail, flooding the conning tower. If they hit the bottom, they could damage the propellers or the rudder. Trapped between the roof and the floor, Anderson realized he had lost the maneuvering room required to survive. He was driving a 300-foot steel tube into a vise that was slowly tightening. And then the ultimate anomaly appeared. The sonar showed a massive ridge of ice ahead. It went down and down. It extended more than 80 feet below the surface. At the same time, the seafloor rose. There was no gap. Or if there was a gap, it was too small to risk a nuclear reactor. Anderson faced the hardest decision of his career. The White House was waiting for a victory. The Navy was waiting for a vindication of nuclear power. His crew was ready to go. The North Pole was just a few hundred miles north. But William Anderson was not a reckless man. He was a mathematician of risk. He looked at the numbers. He looked at the sonar. He calculated the odds of getting stuck. If the Nautilus became wedged between the ice and the bottom, there would be no rescue. The icebreakers couldn't reach them in time. They would not be heroes. They would be a tragedy. They would be the crew that lost the world's first nuclear submarine in a frozen tomb. He made the call. "Reverse course," Anderson ordered. "We are turning back." The Nautilus executed a delicate, heart-stopping turn in the shallow water, her tail clearing the ice by inches. They retreated south, back into the open water of the Bering Sea. The first attempt was a failure. When Anderson reported the abort to his superiors, there was disappointment, but also relief. He had brought the ship back. He had not thrown it away on a gamble, but this failure was necessary. It provided the data they lacked. It proved that the shallow entry route through the Chukchi Sea was impassable due to the deep draft ice. They couldn't go through the ice, they had to go under it. They needed deeper water. Anderson returned to Pearl Harbor. To the press and the public, it looked like a routine return from exercises. But in the briefing rooms, Anderson and his navigators were poring over the charts. They discovered a feature that had been overlooked: the Barrow Sea Valley. It was a deep underwater canyon, a trench that cut through the continental shelf near Point Barrow, Alaska. It was a narrow, deep highway that led directly under the polar pack. If they could find the entrance to this valley, a navigational challenge in itself, they could slip below the pressure ridges. They could dive to 400 feet, well below the deepest ice keels. It was a backdoor, but the window of opportunity was closing. The Arctic summer was short. The ice was thickening, the daylight was fading. Anderson knew he had to go back immediately. He couldn't wait for next year. The political pressure of Sputnik was still weighing on the president. The Navy needed this win now. The crew of the Nautilus was tired. They had just spent weeks at sea, but Anderson rallied them. He didn't tell them the full details. Secrecy was paramount, but he told them they were going back north. The second attempt would be different. They were not probing, they were committing. Once they entered the Barrow Sea Valley and went under the permanent polar pack, there would be no turning back. They would be committed to a transit of nearly 2,000 miles without surfacing. This was the dangerous idea fully realized. They were going to sever their connection with the atmosphere for days. They would rely entirely on the reactor for air, heat, and water. They would rely on the gyroscopes for direction. As the Nautilus headed north for the second time in late July 1958, the stakes had shifted. The first attempt had been a reconnaissance. The second attempt was an invasion of the unknown. Anderson stood on the bridge as they approached the ice edge again. The air was biting cold, the sea was gray and hostile. He looked at the white line on the horizon, the pack ice. To the Soviets, that ice was a wall. To the surface navy, it was a hazard. But to Anderson, it was a veil. He knew that on the other side lay the answer to the strategic dilemma of the age. He ordered the bridge cleared. He dropped down the hatch. The steel sealed shut. The diving ship was gone. The true submersible was about to begin its work. The failure of the first attempt had taught them humility. It had taught them that the ice could not be bullied, it had to be outsmarted. Now, armed with the knowledge of the canyon and the discipline of the abort, Anderson was ready to try again. The Nautilus slipped beneath the waves. She turned her bow toward the Barrow Sea Valley. She was leaving the world of maps and entering the world of probability. The most dangerous idea of the Cold War was no longer a plan on a desk in the Pentagon. It was a 3,000-ton steel shark moving silently through the deep, heading for the roof of the world. On the morning of August 4, 1958, the USS Nautilus is running on the surface of the Chukchi Sea, a gray, desolate stretch of water between Alaska and Siberia. The air temperature is 30 degrees Fahrenheit. The wind is cutting. Ahead, filling the northern horizon from east to west, is the white, jagged line of the polar ice pack. To the uninitiated, the ice looks static. It looks like land. But to Commander William Anderson, standing on the bridge for the final time before the descent, it looks like a locking mechanism. He knows that once he takes his ship beneath that line, the world he understands, the world of waves, weather, and radio waves, will cease to exist. He will be entering a sealed hydraulic system where the pressure is constant, the sun is a memory, and the only way out is thousands of miles away. Anderson gives the order to clear the bridge. The lookouts descend. The heavy steel hatch clangs shut. The wheel is spun, dogging the seal against the gasket. In that moment, the Nautilus transforms. It stops being a ship and becomes a spacecraft. The environment inside the hull, 72 degrees, fluorescent lit, smelling of coffee and floor wax, is now a self-contained bubble of humanity severed from the biosphere. Dive, dive, the vents open. The sea rushes into the ballast tanks. The Nautilus slips beneath the waves. The rolling of the surface swell vanishes, replaced by the smooth, eerie stability of the deep. The mission has begun. But the first challenge is not the pole, it is the door. Anderson is aiming for the Barrow Sea Valley. This is the deep underwater canyon discovered on the charts after the failed first attempt. It is the only known gap in the continental shelf deep enough to allow the Nautilus to slip under the pressure ridges without scraping the bottom. But finding the entrance to a submerged canyon in waters with poor charts, using navigation systems that are struggling with the proximity to the magnetic North Pole, is a feat of blind precision. As they approach the ice edge, the sonar paints a picture of the ceiling. The flat surface of the water is replaced by a chaotic, jagged landscape. On the upward-looking sonar screens, the ice looks like an inverted mountain range. Massive keels of ice, formed by the crushing together of flows, stab downward into the dark. Some of these keels are small, 10 or 20 feet. Others are monsters, extending 60 feet or more deep. They hang like daggers, waiting to snag the sail of the submarine. Anderson orders the boat down, make depth 400 feet. The Nautilus descends into the Barrow Sea Valley. The sonar shows the canyon walls rising on either side. The bottom drops away. They have found the channel. They are under the pack. Now the true test of the technology begins. Navigating a submarine at the top of the world is a nightmare of physics. A standard magnetic compass is useless. The magnetic lines of force are vertical here, causing the needle to spin aimlessly. A standard gyro compass, which relies on the rotation of the Earth to find true north, loses its accuracy as it approaches the axis of rotation. The drift, the error rate, increases exponentially. If the Nautilus loses its heading, it will be trapped. It will wander in circles under the ice until the reactor fuel runs out. To solve this, the Navy has outfitted the Nautilus with a piece of technology stolen from the future, the N-6A Inertial Navigation System. Originally designed for the Air Force's Navajo cruise missile, the N-6A uses accelerometers and gyroscopes to track the ship's movement in three-dimensional space without any external reference. It feels the ship move. It calculates position based on pure math. But the N6A is experimental. It has never been tested under the ice for this duration. Anderson watches the readouts with a mix of trust and skepticism. He is betting his life on a machine that thinks for itself. As the Nautilus pushes north, the reality of the unknown becomes visceral. The crew, usually busy with the routine of the watch, finds themselves drawn to the sonar repeaters and the closed-circuit television screens. The TV cameras mounted on the sail and pointed upward show a world of ghostly beauty. The floodlights illuminate the underside of the ice. It is not white. It is a translucent, shifting blue-green. Clouds of algae cling to the bottom of the floes. Strange, jellyfish-like creatures drift in the current. It looks like the sky of an alien planet, but the beauty is deceptive. The sonar recorder, a stylus scratching a line on a moving roll of paper, tells the truth. The ceiling is erratic. The Nautilus is flying through a tunnel that changes shape every second. Suddenly, the bottom of the ocean begins to rise. They are passing over the Lomonosov Ridge, a massive underwater mountain range that bisects the Arctic Ocean. The depth under the keel decreases. Simultaneously, the ice overhead thickens. The tunnel is narrowing. Anderson stays in the control room. He does not sleep. He drinks coffee, chain smokes, and watches the distance between the keel and the bottom, and the sail and the ice. At one point, the sonar picks up a massive object ahead. It is an ice keel of unprecedented size. It hangs down more than 70 feet. The Nautilus is moving at 20 knots. At that speed, a collision with ice would not just dent the sail, it would rip it off. The breach in the pressure hull would be catastrophic. The water would rush in at hundreds of pounds per square inch. Anderson has seconds to react. He cannot turn. The canyon walls are too close. He has to dive. Flood negative, down angle 20. The ship lurches, the deck tilts steep. The Nautilus dives for the bottom. They pass under the ice keel with feet to spare. The sonar trace shows the jagged dagger of ice passing directly over the sail. The sound of the clearance is silence, but the feeling in the control room is a collective gasp. They level off. The water deepens again. They are past the ridge. But now, a new danger emerges: the isolation. In the Atlantic, a submarine can raise a VLF, very low frequency, antenna to receive messages. Under the ice, radio waves are blocked. The Nautilus is completely cut off from the human race. If a war starts, they will not know. If the president cancels the mission, they will not know. They are operating in a vacuum. The psychological weight of this isolation begins to press on the crew. There is no rescue. There is no plan B. If the reactor scrams and cannot be restarted, they will not drift to the surface. They will drift up to the ice, pin against it, and freeze. The technical hell of the mission is the constant management of these risks. The crew monitors the atmosphere. They check the radiation levels. They watch for leaks. Every system on the boat is critical. The silence of the ship is different here. In the open ocean, you hear the waves. Here, you hear the ice. It groans. It cracks. It sounds like thunder or like heavy machinery dragging across concrete. It is the sound of the lid shifting. As they approach the high latitudes, the navigation becomes purely abstract. The concept of east and west ceases to have meaning. The longitude lines are converging so fast that the ship crosses a time zone every hour. The crew is living in a world where time is broken. Anderson orders the ship to switch to grid north. This is an artificial coordinate system used near the poles. It aligns the ship not with the Earth, but with a mathematical grid overlay. It is the only way to steer a straight line when the compass is spinning. They are now deeper into the Arctic than any ship has ever gone. They are passing the point of no return. The distance to the Atlantic is now shorter than the distance back to the Bering Strait. The crew begins to feel a sense of destiny. They are not just sailors, they are explorers. They are going where the map is blank. On August 3rd, 1958, the navigator, Lieutenant Shep Jenks, looks up from his console. He checks the N6A. He checks the gyro. He checks the depth. "Captain," he says, "we are close." The Nautilus is approaching the singularity, the mathematical point where all lines meet, the top of the world. Anderson looks at the electronic log. The distance counter is clicking down. The latitude readout is climbing. 89 degrees, 50 minutes. 89 degrees, 55 minutes. The tension in the control room is not fear anymore, it is anticipation. They are about to drive a stake through the heart of the impossible. But even here, the ice refuses to make it easy. The sonar shows the ice thickening. The pressure ridges are getting deeper. The fortress is thickest at the center. Anderson holds the course. He trusts the depth. He trusts the steel. The Nautilus drives forward, a nuclear arrow aiming for the bullseye of the planet. The unknown has become the known. The blank spots on the chart are being filled in with soundings and speed logs. They are about to do what Shackleton, Amundsen, and Peary could only dream of. They are about to cross the pole without getting their feet wet. But as the countdown to 90 North begins, Anderson knows that reaching the pole is only the halfway mark. The exit is often harder than the entry. The Atlantic side of the Arctic is known for even heavier ice, wilder currents, and the hunting grounds of the Soviet Navy. They have entered the unknown and survived. Now they have to survive the victory. On the night of August 3, 1958, inside the steel hull of the USS Nautilus, the concept of location ceases to have any physical meaning. The submarine is moving at 20 knots, 400 feet below the surface. Above it lies 10 feet of solid ice, and above that, the freezing wind of the polar cap. But inside the control room, the entire universe has shrunk down to a single row of Nixie tubes glowing on the face of the inertial navigation system. The countdown to the North Pole is not a visual event. There is no mountain to climb, no flag to plant, no horizon to scan. It is a purely mathematical conquest. The navigator, Lieutenant Shep Jenks, watches the latitude readout climb with a hypnotic rhythm. 89 degrees 58 minutes, 89 degrees 59 minutes. At 11:15 p.m. Eastern Daylight Time, the numbers roll over, 90 hours north. The Nautilus passes directly beneath the geographic North Pole. In that second, the ship occupies a singular point in space where all the meridians of longitude on Earth converge. For a brief, fleeting moment, the concept of east and west vanishes. Every direction the crew looks is south. They are standing on the pivot point of the planet. Commander William Anderson picks up the microphone of the ship's announcing system. His voice is calm, betraying none of the exhaustion that comes from days of sleepless monitoring. All hands, this is the captain. 10, 9, 8, 3, 2, 1. Mark. August 3rd, 1958, 23:15 Eastern Daylight Time, for the United States and the United States Navy, the North Pole. A cheer goes up through the boat. In the mess hall, where the crew has gathered, the tension of the last few days breaks. They shake hands. They pat each other on the back. A sailor dressed in a makeshift Santa Claus costume made of red bunting and cotton balls walks through the compartments, a surreal touch of humor in the most desolate place on Earth. Anderson famously signs a letter to President Eisenhower, postmarked North Pole, a piece of mail that has traveled a route no postman had ever taken. But the celebration is restrained. There is no champagne. Alcohol is forbidden on U.S. Navy ships. There is a cake, baked by the ship's cooks, decorated with a crude map of the pole. And there is a moment of silence. The crew understands the gravity of what they have done. They have not just broken a record, they have broken a barrier. For centuries, men had died trying to reach this spot. They had frozen to death, starved, or vanished into the whiteout. The Nautilus has arrived with the crew drinking coffee in their shirt sleeves, powered by the splitting of the atom. It is the ultimate triumph of technology over nature. However, for Anderson and the navigation team, the arrival at the pole is the easy part. The departure is the nightmare. The North Pole is a navigational singularity. When you cross it, your compass spins. Your gyroscope tries to flip over. The grid north system they are using holds steady, but the transition from approaching the pole to leaving the pole requires a precise mental shift. If they make a wrong turn now, they won't head toward the Atlantic. They will head back toward Siberia, or worse, get lost in the infinite loop of the high latitudes. Anderson orders the ship to maintain course. They are driving down the other side of the world. But as the Nautilus moves away from the pole, heading toward the Greenwich Meridian and the Atlantic Ocean, the environment outside the hull begins to change, and it changes for the worse. The ice on the Pacific side of the Arctic, the side they had just traversed, is relatively young. It drifts freely. But on the Atlantic side, the massive transpolar drift stream pushes the ice pack against the coast of Greenland and the Canadian archipelago. The pressure is immense. This compression creates ice that is older, harder, and significantly thicker. The pressure ridges here are not just frequent, they are monstrous. As the Nautilus enters the Greenland Sea, the sonar trace of the ceiling becomes jagged and violent. The inverted mountains are reaching deeper. Keels of ice extend 80, 90 feet down. At the same time, the ocean floor begins to rise again. They are entering another funnel similar to the one that had forced them back in the Bering Strait, but this one is made of harder ice and colder water. Anderson watches the upward-looking sonar. The trace looks like the EKG of a heart attack, spikes of ice plunging down toward the sail. "Depth check," he orders. The clearance is shrinking. The Nautilus is sandwiched. If they go deeper to avoid the ice, they risk hitting the bottom. If they come up, they risk the sail. The crew's euphoria fades. They are back in the gauntlet. The ship is silent again, rigged for ultra-quiet, not to hide from the Russians, but to listen for the ice. The hull groans. The water temperature drops to 28 degrees Fahrenheit. The steel contracts. Anderson knows that the exit is statistically more dangerous than the entry. They are tired. The equipment has been running without a break for days. The N6A navigation system, the miracle machine that has guided them this far, is starting to show signs of drift. If the navigation fails now, they will be lost under the heaviest ice in the northern hemisphere. The hours drag on. The Nautilus weaves through the underwater canyons. They dodge ice keels that would crush the hull like an eggshell. The sonar operators are not looking for enemy submarines. They are looking for the topography that wants to kill them. Then, slowly, the sonar picture begins to change. The jagged spikes of the ice ceiling begin to smooth out. The frequency of the pressure ridges decreases. The water darkens as the ice thins, allowing the faintest glimmer of light to penetrate from the surface. They are reaching the marginal ice zone, the breakup area, where the solid pack gives way to open water. On August 5, 1958, the sonar shows clear water overhead. Anderson waits. He wants to be sure. He doesn't want to surface through a rogue flow that could damage the rudder or the propellers at the last second. Finally, the order comes. Surface! Surface! The Nautilus angles up. The ballast tanks blow. The submarine breaches the surface of the Greenland Sea. For the first time in 96 hours, the hatch opens. Anderson climbs to the bridge. The air is cold, but it is fresh. It smells of salt and the sea, not the recycled ozone of the boat. He looks around. There is ice in the distance, but the water around the ship is open. They have made it. The radio operator raises the antenna. The silence of the Arctic is broken. Anderson dictates a message to the Chief of Naval Operations in Washington. It is brief, coded, and destined to become legendary. Nautilus 90 North. 3 words. But they carry a weight that will shift the geopolitical axis of the world. The message is relayed via a listening station in Iceland to the Pentagon and then to the White House. When President Eisenhower receives it, he knows that the gamble has paid off. The United States has successfully flanked the Soviet Union. But the immediate reaction is not public. The Nautilus is still in dangerous waters. She is now on the NATO side of the line, but Soviet submarines prowl these seas too. Anderson keeps the ship moving, heading south at high speed, racing toward Iceland and then England. The moment no one saw is over. The transit is complete. The Nautilus has effectively vanished from the Pacific and reappeared in the Atlantic, traveling a route that no surface ship could follow. As the news breaks to the world a few days later, the reaction is seismic. In New York, ticker tape parades are planned. In London, the newspapers hail the Columbus of the atomic age. But in Moscow, the reaction is one of shock and strategic horror. The Soviet Naval Command had believed the Arctic was their fortress. They believed their northern flank was secure. Now they have to face the reality that an American nuclear submarine has just driven a truck through their backyard. The unwritten law is dead. The Arctic is no longer a wall. It is a contested battle space. For the crew of the Nautilus, the mission is a triumph. They are heroes. They receive the Presidential Unit Citation, the first ever awarded in peacetime. Anderson is awarded the Legion of Merit. But for the strategists, the mission is a beginning, not an end. The Nautilus proved it could be done. Now, they have to build the ships that will live there. The success of Operation Sunshine accelerates the development of the George Washington class, the ballistic missile submarines. If the Nautilus can transit the pole, a missile submarine can hide there. The under-ice arms race has begun. Anderson stands on the bridge as the Nautilus steams toward Portland, England. He watches the Atlantic swells. He thinks about the ice. He knows that he has opened a door that can never be closed. The Arctic Ocean, once the preserve of silence and white darkness, is about to become the hiding place for the apocalypse. The Nautilus blazed the trail, but the machines that follow her will carry weapons that can melt the ice from below. The exit had been dangerous, but the Nautilus survived. The question now is whether the world can survive the new reality she has created. The submarine dips beneath the waves again, heading home. She is no longer just a ship. She is a legend, but she is also a warning. The impossible is now doctrine, and the ice is no longer safe. The telegram sent by Commander William Anderson, Nautilus 90 North, was more than a navigation report. It was a geopolitical earthquake that fractured the strategic bedrock of the Soviet Union. For 4 days, the USS Nautilus had effectively vanished from the board. She had slipped into the blind spot of the world, traversing the one region that Moscow believed was impenetrable. When she resurfaced in the Atlantic, shaking the ice from her deck, she shattered the illusion of the Soviet Arctic fortress. The reaction in the Kremlin was a mixture of professional admiration and strategic terror. The Soviet Naval High Command had spent decades building a defense based on the assumption that the Arctic was a wall. They had fortified their western approaches in the Baltic and the Black Sea. They had guarded the Pacific, but the North had been left relatively open, protected by the hostile geography of the pack ice. Now, the Americans had proven that the wall was a door. The implications were immediate. If an attack submarine like the Nautilus could cross the pole undetected, then a ballistic missile submarine could do the same. The Soviets realized that the United States could park a vessel loaded with nuclear warheads in the chaotic acoustic environment of the Arctic, hiding among the ice keels, listening to the groans of the floes, and waiting to launch a strike that would reach Moscow in less than 15 minutes. This realization triggered the most expensive and technologically aggressive arms race in naval history. The Soviet Union could no longer ignore the ceiling of the world. They had to contest it. The direct result of the Nautilus mission was the birth of the Soviet under-ice fleet. The design bureaus were ordered to build submarines capable of fighting in the three-dimensional maze of the Arctic. This drive led to the creation of the Alpha class, titanium-hulled interceptors designed to sprint deep and fast to catch American intruders. It led to the Typhoon class, massive, double-hulled leviathans designed specifically to break through the ice from below to launch their own missiles. The Arctic Ocean transformed from a silent wilderness into a crowded, secret battlefield. The white void on the map became a grid of sonar nets, patrol zones, and ambush points. The Nautilus had not just crossed an ocean, she had opened a new front in the Cold War. But the legacy of the mission extended far beyond the cat-and-mouse games of attack submarines. The Nautilus paved the way for the ultimate logic of the nuclear age: mutually assured destruction, MAD. Before 1958, the concept of a secure second strike was theoretical. Land-based missiles were vulnerable. Bombers could be shot down, but a nuclear-powered submarine hiding under the polar cap was, for all practical purposes, invincible. The Nautilus proved the transit was possible. 2 years later, the USS George Washington proved that a missile could be launched from underwater. When these two capabilities were combined, the strategic math became absolute. If the United States could hide its weapons where the Soviets couldn't find them, the Soviets could never launch a surprise attack without guaranteeing their own destruction. And once the Soviets developed their own under-ice capability with the Delta and Typhoon classes, the standoff became mutual. The stability of the Cold War, the grim peace that held for 40 years, was built on the foundation laid by William Anderson. By proving that the ice was permeable, he helped create a system where war became impossible to win. The Nautilus was an instrument of exploration that became an instrument of stability. For the man himself, the legacy was complex. Commander Anderson did not become a career admiral in the mold of Halsey or Nimitz. He was not a man who sought the limelight of command for its own sake. After the mission, he was feted as a hero. He wrote a best-selling book, Nautilus 90 North. He was pinned with the Legion of Merit by the president. But Anderson was a quiet professional. He eventually left the Navy and entered politics, serving as a congressman for Tennessee. In the halls of Washington, he was known for his thoughtful, analytical approach, the same mathematics of risk that had guided him through the Barrow Sea Valley. He rarely spoke of the terror of the ice keels or the claustrophobia of the sealed hull. He spoke of the crew. He spoke of the engineering. He understood that he was not a conquistador. He was a pilot who had been given a magnificent machine and told to fly it to the edge of the envelope. His decision to turn back during the first attempt remains his most underrated act of leadership. A lesser man, driven by ego or the pressure of Sputnik, might have pushed the Nautilus into the shallow ice of the Chukchi Sea and lost her. Anderson's willingness to accept a necessary failure ensured the ultimate success of the mission. He proved that in the unforgiving environment of the Arctic, patience is a weapon. As for the ship, the USS Nautilus served for another 2 decades. She patrolled the Mediterranean, the Atlantic, and the Caribbean. She participated in the quarantine of Cuba. But she was a prototype, and prototypes age quickly. By the late 1970s, she was noisy, slow, and mechanically tired compared to the sleek Los Angeles-class boats that followed her. In 1980, she was decommissioned. Most warships, even the famous ones, end their lives in a scrapyard. The USS Enterprise, CV-6, the most decorated ship of World War II, was cut up for razor blades. But the Nautilus was saved. She was designated a National Historic Landmark. Today, she sits at a pier in Groton, Connecticut, just down the river from where she was born. She is a museum ship. Tourists walk through her narrow corridors. They look at the small bunks where 98 men slept. They peer into the glassed-off control room, looking at the analog gauges and the heavy steel valves. It is difficult for a visitor to reconcile the quiet, smelling of paint museum with the technical hell of 1958. The ship feels small. It feels fragile. It is hard to imagine this steel tube driving blindly into a tunnel of ice, thousands of miles from help, powered by a reactor that was the first of its kind. But if you look closely at the navigation station, you can see the N6A system. It is silent now, its gyroscope still, but it is the device that found the needle in the haystack. The Nautilus is no longer a weapon. She is a witness. She stands as a physical testament to a moment when the human race decided to stop looking at the horizon and start looking beyond it. The philosophical conclusion of the Nautilus story is a reflection on the nature of limits. For centuries, the Arctic ice was considered a law of nature. It was a here be dragons zone on the map, a place where ships could not go. The ice was hard, steel was soft. The logic was circular and complete. But the Nautilus proved that limits are often just assumptions waiting to be challenged. The barrier wasn't the ice. The barrier was the propulsion. Once the technology changed, once the need for air was removed, the geography changed with it. We see this pattern repeated throughout the history of technology. The sound barrier, the gravity well of Earth, the depths of the Mariana Trench. These were all considered walls until someone built a machine that turned them into doors. The Nautilus reminds us that the impossible is usually just a temporary state of engineering. However, there is a darker side to this legacy. By opening the Arctic, the Nautilus also militarized the last pristine wilderness on Earth. Before 1958, the North Pole was a place of silence and science. After 1958, it became a hiding place for megatons of nuclear explosive. The ice, which had protected the Arctic ecosystem for millennia, became a ceiling for war. The silence was broken by the ping of active sonar and the cavitation of propellers. Today, the Arctic is changing again. The ice is thinning. The permanent pack that Anderson navigated is melting. The multi-year ice that threatened to crush the sail is disappearing. Surface ships, tankers, container vessels, and destroyers are now pushing into the waters where only the Nautilus dared to go. The highway that Anderson opened is becoming a literal shipping lane. Nations are vying for control of the seabed resources. The strategic competition that began in the dark of 1958 has moved into the daylight. But the Nautilus remains the pioneer. She was the first. She went when the map was blank. As we leave the story of Operation Sunshine, we are left with the image of the submarine hovering at 90 degrees north. There were no flags planted, no footprints left in the snow, just a digital readout on a screen in a warm room under the ice. It was a quiet conquest. It was a victory of math, steel, and nerve. The world realized the truth only after the ship had already left. The Arctic was no longer a wall, the oceans were one, and the safety of distance was gone forever. The Nautilus proved that there is no place on Earth that is beyond reach. It is a lesson that resonates in every satellite orbit, every deep-sea cable, and every stealth aircraft flight path today. We live in a world without walls because ships like the Nautilus knocked them down. The ice reforms, the snow covers the tracks, but the path remains. The Nautilus showed us the way, and the world followed her into the cold, bright future. The voyage of the USS Nautilus is a defining moment of the 20th century, not because it was a battle, but because it was a breakthrough. It demonstrated that the Cold War would be fought not just with firepower, but with brain power. It was a conflict of physicists, navigators, and engineers. William Anderson and Hyman Rickover were not typical warriors. They were architects of a new reality. They looked at a frozen ocean and saw a solution to a global stalemate. As we look at the museum ship today, resting quietly in the Thames River, we should remember the moment when the hatch sealed off the sky in the Bering Strait. We should remember the fear of the inverted mountains. And we should remember the courage it took to drive into the dark, trusting nothing but a gyroscope and the skill of the crew. The Nautilus taught us that the world is only as small as our courage allows it to be. If this deep dive into the hidden history of the Cold War and the exploration of the last frontier meant something to you, we'd be honored to have you with us again. Until next time, stay curious and take good care.